Determine whether the second polynomial is a factor of the first. Well, to determine if a factor is a factor of a particular polynomial, we need to equivalently determine if it happens to be a zero. So to find out if it's a zero, we change this into a zero. So it's in the factor x minus 1 has a zero at positive 1. So the question is f evaluated at 1 equal to 0? Because if it is, then 1 is a 0, which means x minus 1 is a factor. So let's see. To evaluate quickly, we can use synthetic division. So I'll just take 1 into this polynomial. So the coefficients are 1, -5, 3, and 1. So bring 1 down. 1 times 1 is 1. That adds up to -4. 1 times -4 is -4. So that adds up to -1. 1 times -1 is -1, and the sum of this column is 0. So it turns out that it is in fact a 0, so therefore x minus 1 is a factor of the polynomial defined by f of x. All right, let's try the next one. So again, we take this factor and we identify its 0. So the 0 of this factor is -4. And what I want to do is evaluate this particular polynomial at -4 to see if I get 0 as a result. And the remainder theorem says that I can do that with synthetic division instead of plugging the number in. So we'll bring the 6 down. 6 times -4 is -24. And then if I do 13 minus 24, that's -11. -4 times -11 is positive 44. 44 minus 14 would give me 30. And -4 times 30 would be -120. So the sum of these two is -117, it looks like, which is not equal to 0. So no, x plus 4 is not a factor of this polynomial.